Welcome to The Explainer. You know, in the world of AI, you might be surprised how often some of the biggest decisions come down to, well, just a gut feeling. Today, we're going to look at a really cool breakthrough that's all about replacing that guesswork with actual precision. We're talking about making AI smarter, faster, and way more reliable. Okay, so let's kick things off with a classic dilemma, one I'm sure you've heard before. Fast, cheap, or good? The old saying goes, you can only pick two. It's this constant trade-off we're always forced to make, right? Well, it turns out that exact problem is a massive, constant headache in the world of AI.
So here's what we're going to cover. We'll start with this big juggling act in AI, look at the old way of doing things, which, spoiler, has a big flaw, and then get to the really exciting part, the automated solution that kind of changes everything.
All right, Section 1, the juggling act. Now, the fancy term for this is multi-objective optimization. And trust me, it's a challenge you see everywhere. I mean, from designing a new car to managing a stock portfolio. The whole idea is you're trying to make a bunch of different things better at the same time, even when they're fighting against each other. And in AI, this juggling act is just constant. Think about it. You want a model that's super accurate, right? But at the same time, you can't have it be so complicated that it's crazy slow, costs a fortune to run, and is impossible to figure out. It's this really delicate dance between performance and efficiency. Okay, so how have people been dealing with this? Well, one of the go-to methods is something called the lexicographic approach. It sounds complicated, but the idea is actually super simple. You just make a list and rank your goals from most important to least important. What's so great about this method is that it's all about that hierarchy. It lets you tell the system, look, your number one job is to get the best accuracy you possibly can. Got it? Okay. Once you've done that, then, and only then, try to make the model as simple and efficient as possible without messing up that accuracy. It's a really clear step-by-step way to attack the problem. But, and you knew there was a but coming, right? This seemingly powerful, really logical method has a huge weakness. A hidden flaw that's been holding it back for years, and it's been right there, hiding in plain sight the whole time. So where's the flaw? It's all in this one tiny setting called the tolerance parameter. Think of it as a wiggle room knob. It basically tells the model, hey, how much are you willing to compromise on your top priority to make progress on the next one? Like, are you okay if accuracy dips just a tiny bit if it means you get a massive boost in speed? That's what tolerance is all about.
And this is where it gets kind of crazy. The researchers point out that for years, this absolutely critical number was just a guess. People were literally just picking a value that felt right. It was totally ad hoc, which is just a fancy way of saying they were winging it.
And you can imagine this caused a huge problem. When you're just guessing, your results are all over the place, inconsistent, and definitely not the best they could be. So the challenge was set. Could someone, anyone, figure out a way to automate this? To find that perfect tolerance value without any of the guesswork. And that, of course, brings us to the solution. This is where a new algorithm enters the picture. It's kind of the hero of our story today. Researchers designed it specifically to solve this exact problem, once and for all. The way it works is just brilliantly systematic. Instead of a human guessing one number, the algorithm just says, forget guessing, I'm going to test a whole bunch of them. So it takes a whole range of possible tolerance values, and for every single one, it trains a complete neural network from scratch. Then it looks at the performance of all those models and figures out which one found that perfect sweet spot balance.
Okay, so that's the theory. Sounds great on paper, right? But the big question is, did it actually work in the real world? The researchers tested it on several different datasets, and honestly, the results they got back were pretty fascinating.
What they found was what you could call a Goldilocks zone. It wasn't about one single magic number. It was a very narrow range of values where everything was just right. If the value was too low, nothing really improved. But if it was too high, whoa, things went off the rails fast.
So let's look at what happens when you get it wrong. They used a really famous data set of handwritten numbers called MNIST, and they found that if they set that tolerance value just a little too high, the model's accuracy completely cratered. I mean, it went from over 96% all the way down to just 9%. The model basically just broke.
But when they were right inside that Goldilocks zone, the algorithm found the absolute perfect number. And with that one precise setting, it took a pretty simple neural network and boosted its accuracy to an incredible 97.32%. That's what precision gets you.
Okay, so why is this such a big deal? I mean, we're talking about one little parameter, right? But it's about so much more than that. This really represents a huge shift in how we build AI, moving away from guesswork and towards real, hard-nosed precision. Think of it this way. We're shifting from AI development being an art, based on intuition and gut feelings, to it being a science based on systematic, repeatable tests. What this proves is that the perfect setting is different for every single problem. And that's exactly why just guessing was always such a bad idea. Ultimately, this makes building AI more reliable, more efficient, and it helps us unlock the true power of the tools we've already got.
And that leaves us with a really big question to think about. This one little breakthrough took something that was a total guess and turned it into a precise science. So it makes you wonder, what happens when we start applying that same kind of systematic thinking to all the other parts of building AI that are still based on hunches and trial and error? Just what kind of potential are we about to unlock?